Good evening, friends. Myself, Dr. M.H. Annaya, and in today's video, we are going to learn how to obtain the sectional views of a square prism when it is cut by a vertical section plane. And friends, for today's video, we have the question running like this. A square prism of side 30 mm resting on a square face on HP. So the question is on a square prism which has got a square base and a square top, and they have specified what the size is having 30 millimeter. Each side measures 30 mm, and all the shorter edges are equally inclined to VP. So while resting on HP on one of its square faces, all the four shorter edges AB, BC, CD and DA are equally inclined to VP. That means when you see from the top, you will be able to get a figure like this, a square with all the sides equally inclined to VP. And the same problem can be stated in a different way also. That is, all the four lateral rectangular surfaces are equally inclined to VP. Okay, so friends, we will place the prism on HP with all the four edges equally inclined to VP. Obtain the top view and front view. In the top view, you are going to get a square with all the edges equally inclined to VP, and in the front view, you will get two rectangles. This is one rectangle, this is the other rectangle. So friends, let us start with the top view of this prism. So we will mark this XY line, mark BP and HP, indicating first angle projection. And now friends, we will construct a square of side is equal to 30 millimeter. So 30 millimeter square you have constructed, we will mark it as 30 SQ. 30 SQ indicates that it is a square of 30 millimeter size. So 30 SQ, and we will label this as ABCD, A, B, C and D. ABCD are the corners of the bottom face, and we will obtain the corresponding front view. So a line from here, a line, another line from here. Friends, we project lines from these four corners. You will get here the bottom face of the solid, and we will mark it as A1 dash, B1 dash, D1 dash, C1 dash, because it refers to the bottom face. And by extending these lines upward, if you extend these lines upward, you can obtain the front view. So this is one line through this, second and third line. So friends, here to complete this view, we need to have the height, but in the question, nowhere you see what the height of the solid is. Then how to obtain it? Friends, it says, when this square prism is cut by a vertical section plane, the section plane is vertical and it is parallel to VP. Friends, let us get the concept of this vertical section plane. Friends, if we have this a vertical section plane which is parallel to VP, you will be able to see the section plane as a line in the top view, this line in the top view. If it is perpendicular to VP and perpendicular to HP, then you will be able to see top view a line, front view also a line. But if it is like this at an angle, again, since the surface is perpendicular to HP, you can see this as a line again in the top view. But here he says the object has to be cut by a vertical section plane which is parallel to VP. Parallel to VP means You are going to see the section plane SS as a line somewhere here. But where to get it? Friends, you say the true shape obtained after cutting should be a rectangle 20 mm by 65 mm. 20 by 65. That means if it is cutting by a vertical section plane like this should have a width equal to 20 millimeter, and the height very obviously should be equal to 65. If it is 20 by 70, we should take height 70 and so on. So friends, I am going to complete this figure, the front view of this, by taking a height is equal to 65 mm. So that 65 millimeter is the height of that rectangle in the front view. So write it as 65 mm. After obtaining this 65 mm, let us complete naming of this. This is A, so this is going to be A dash, B dash, D dash and C dash. O dash is the center of top face, O1 dash is the center of bottom face. The object is resting on HP on one of the square faces. This is how we get the front view and top view. And again, don't forget to mark this double marking in case of prisms and cylinder. This is BB1, CC1, DD1. So DD1 is the vertical edge DD, CC1 is the vertical edge CC, and so on. Friends, here. Now let's move on to getting the position of this section plane. Friends, when you cut it like this, since the section plane is parallel to VP, it is seen as a line, and here we should get a width is equal to 20 mm. So how to obtain that, friends? So anywhere you can take, there are so many methods. See, the one method I do is, I take this, and here friends, I extend this, I draw a line parallel to that XY, and from this I just take 10 mm from both the sides, because 20 I should get as the width. So I'll take 10 mm here, 10 mm here, and project these points there. So you will get one line from here, a line from here, another line from here. Friends, this gap is going to be 20 mm, 10 plus 10. So friends, here I am going to pass or draw the section plane passing through these. I will mark this as S and S. So friends, S and S will represent the section plane which is having, or it is passing at some distance from there, which you are going to find out later on. So friends, after obtaining a section plane, a vertical section plane which is parallel to VP, let us write down the portion of the solid that is left over after throwing away the part near to this. So friends, here this much portion of the solid is retained, this portion is removed. Section below section plane, this is removed, and these are the points you have got. Friend, let me mark this. So where does it cut? It is cutting the top edge AB and also bottom edge A1, B1. So you get 2 points here. Similarly here, the section plane is cutting this BC and also B1, C1. So if you start from this, it is cutting AB and A1, B1. So friends, I can just extend a line from here and show it is cutting at the top face and also bottom face. Likewise, from this if you take, again it is cutting both the top and bottom faces. So one point is here, the other point is here. So friends, basically there are 4 points, 2 on the top face, 2 on the bottom face. We will join all these by straight lines. So this is a straight line, this is another straight line, this is another straight line, and we will number them we'll just number them as, see, you can say anywhere, this is 1, this is 2, this point is 3, and this is 4. Friends, this is the top view of this section. We have got TV and we don't have any hatching to be done here. But here 1, 2, 3, 4, if I just mark them here in the top view, this is 1, comma 4, and this point is going to be 2, comma 3. 2, comma 3, 1, comma 4. And these 4 points you have got is joined by thick lines, and we are going to draw a series of lines inclined at 45 degrees to the horizontal, and we are going to section that. So friends, after sectioning, if you observe the front view, the corner CC is intact, so I will join this by a full line, full vertical line. Edge AA is also retained because section plane is not touching that. This base will be there. And friend, this is how we obtain the sectional front view of the solid. And you will say SFV. SFV means sectional front view. Top view is this figure, is the top view I have shown as TV. And true shape of section. So what is the meaning of true shape? I have told before, true shape is the mirror image of a cut portion of the solid. So if you hold a mirror parallel to this 1, 2, 3, 4, you get this shadow, the hatched shadow in the mirror. That is called a true shape. Friends, if you want to see practically, this is how it will look. So we had this square and we have removed this by a section plane like this, by a section plane, and this is how the prism will look in the front view along with this section. This is point 1, 2, 3 and 4. 4 points are there, and here this figure 1, 2, 3, 4 in the sectional front view will give the true shape of section. So whatever this figure 1, 2, 3, 4, figure 1, 2, 3, 4 is true shape, is the true shape of section. So we can have a conclusion made like here. Whenever any of these prisms, it's not particularly for square, whenever any of the prism, square, triangular, rectangular, whatever it may be, when it is held vertical and cut by a vertical section plane, the vertical section plane, the true shape you obtain here, that is in a case like this, is the true shape of the figure. The hatched portion in the front view is the true shape of the section. And the second important point is, whenever these prisms or cubes or cylinders are cut by vertical section plane, it could be vertical like this, or it could be inclined to VP, or it's perpendicular to both HP and VP, we are going to get the true shape as a rectangle only. And friends, the complete figure above the XY line will give you sectional front view, and the hashed portion 1, 2, 3, 4 will represent the true shape of the section. And friends, we got the true shape of section, and it is a rectangle. If you want, you can just name it. Draw the projections and obtain sectional front view. We have got top view. We have got true shape of section. And he says, specify the location of the section plane from the axis of prism. Friends, the axis of prism is this point, which you call it as O, O1. O is the center of the top face, O1 is the center of the bottom face. And this section plane is parallel to XY, that is a vertical section plane they have specified. And you can say at what distance it is from the axis. So if you measure this distance from OO, this will give you the distance of the section plane from the axis. You can measure that, scale that. Determine the height of the prism. I told you the height depends on the size of the rectangle. If it is 70, height will be 70. If it is 100, 20 by 100 is going to be 20, and this is going to be 100. Friends, we have completed the sectioning and getting all the required views as per the problem specification. Friends, I hope you are happy with the presentation I have made. And if you are really happy with the presentation, do subscribe to my channel and share this information with all your friends. Friends, one more information. Whenever you are going through any of my videos, please go through the complete video and it will help you a lot in getting the fundamental concepts of this subject. Thank you, friends. Have a nice evening.